Hello students, so welcome to today's class. So in this class we will do solution question part 6. In this session we will be practicing question, so there will be questions from 42 to 49. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So your question says that for 1 molar aqueous solution of the following compounds, which one will show the highest freezing point? Your options are A. COH2O whole 6 Cl3, option B. COH2O whole 5 Cl, then outside the coordination sphere it is Cl2 dot H2O. Then option C, we have COH2O whole 4 Cl2, and outside the coordination sphere we have Cl dot 2H2O. Option D, it is COH2O whole 3 Cl3, and outside the coordination sphere it is dot 3H2O. So you have 10 seconds to solve this question. Your time starts now. Okay, your time is up. So in this question, you are given that you have 1 molar aqueous solution of certain compound, and you have to tell that which one has the highest freezing point, right? Which one has the highest freezing point? So your correct option is D. So if I talk about the freezing point depression, so depression in freezing point comes on the addition of solid particle to a pure solvent. Okay, so basically on adding solid particles to the pure solvent, the freezing point of the solvent diminishes, or you can say it not diminishes, it decreases, right? So all the compounds which are given in the question are ionic in nature. How they're ionic? Because the one ion which is outside the coordination sphere is ionizable. Now the Ventov factor will one will be the one which will be the deciding factor, right? That is your I. So this I will decide that what will be your depression and what amount of depression you will see in the freezing point. So the solution with maximum freezing point must have the maximum number of solid particle. What does this mean? So basically, if you look at the formula, which is the modified formula for the depression and freezing point, delta TF equal to IKFM. So more is the value of I, that is more is your depression, and value of I is nothing is your number of particles, right? So if your number of particle is a minimum, that means you will see a minimum depression in freezing point. Means the freezing point will not be decreased that much, and hence it will be maximum. So this generalization can be done with the help of Ventov factor I, that is number of solid particle, which is directly proportional to I. So from that we can say that solution with maximum freezing point will be the one with the minimum Ventov factor. Okay, we can just conclude all of this and say it directly. So how we'll calculate for D? For option D, you will see that outside the square bracket we have 3 chlorine atoms, and this thing will be a one entity. Okay, so total of 4 entities will be there, so the Ventov factor will be 4 here. Now if you calculate for the next one, then here we have this Cl2. Okay, that means 2 chlorine atom will be ionizable and one whole complex, that is total number of 3. Okay, so I is equals to 3 in this case. Similarly, if we have only one Cl outside, that means one will be the complex and one will be the Cl minus, so Ventov factor will be 2. And for this one, which is COH2O whole 3 Cl3 dot 3H2O, the Ventov factor will be 1. Why it is 1? Because there are no chloride ions present that are ionizable. Okay, so it will not show any ionization, and hence we can say that this complex, which is having no chloride ions outside the square bracket, will have the minimum number of particles, as its I factor is the minimum of all. So freezing point of this complex will be maximum. Here, so we have said it in this discussion part, that the one with the lowest value of I will have the minimum depression in freezing point. Therefore, it will be the one having the highest or the maximum freezing point. Clear? Next question. The freezing point of benzene decreases by 0.45 degrees Celsius when 0.2 gram of acetic acid is added to 20 gram of benzene. If acetic acid associates to form a dimer in benzene, percentage association of acetic acid in benzene will be, so Kf for benzene is given, it is 5.12 Kelvin kg per mole. Options are A 64.6%, B 80.4%, C 74.6%, and D 94.6%. Now in this question, it is said that your freezing point, that is your depression in freezing point value, is 0.45 degrees Celsius. Okay, so this is decreased by 0.45 degrees Celsius. And when it is decreased, when we are adding 0.2 gram of acetic acid, right? This thing is added to 20 gram of benzene. So when we are adding 0.2 gram of acetic acid to 20 gram of benzene, then your freezing point is decreased by 0.45 degrees Celsius. Now, if you have said that your acetic acid is associating in benzene to form a dimer, then what is the percentage association given this data, which is Kf for benzene is 5.12 Kelvin kg per mole. So your correct answer will be D. So to calculate the degree of association of acetic acid, we will assume it as alpha. Okay, so let us assume that the degree of association of acetic acid is alpha in benzene. Now this will be your dimerization reaction. 2 moles of acetic acid will dimerize to form one entity as a whole. So if I consider that your initial mole is 1, okay, and your initial mole for your acetic acid is 0, then what will be the moles at equilibrium? It will be 1 minus alpha. Alpha is simply what? Degree of association. So since your 1 is your initial value, so therefore moles at equilibrium will be 1 minus alpha. Now if alpha molecules are broken, then how many molecules of this acetic acid will be formed? So 2 moles is forming 1. So 1 mole will form 1 by 2, or in this case alpha will form alpha by 2. Now if I calculate the total number of mole, this will be 1 minus alpha plus alpha by 2, that will be equals to 1 minus alpha by 2. Or we can write I is equals to 1 minus alpha by 2. So this is nothing but I, we know that. So what is the depression in freezing point? It is given by delta TF is equals to I KFM. So we are using this equation, and now we will know the value of I also. So Kf is what? Molar depression constant, we know it very well, and m is your small m is your molality. Right? Now what is the formula for molality? It is number of moles of solute by weight of solvent. So number of moles of solute will be 0.2 into how much? 1000 by 16 to 20. So this thing is your what? 0.2 by 60 is your what? It is the number of moles of solute. Right? And 20 by 1000 is your mass in kg. So with the help of this, we can calculate your molality, which is 0.166 mole per kg. So if you put this thing here, you will get 0.45, which is the depression. 1 minus alpha by 2. This thing is your what? This thing is your 5.12 is your Kf value, and 0.166 is your molality. If I calculate it further, you will get this equation by multiplying, cross multiplying 5.12 on the left side and 0.16 is on the also on the left side. Okay, we just cross multiplied it. Solving this whole multiplication, we will get 0.527, which is equals to 1 minus alpha by 2. Or we can write alpha by 2 is equals to 1 minus 0.527. It is clear from this equation. Or at last we can write alpha is equals to 0.946. So this is your what? This is your degree of association. Clear? So your percentage of association will be how much? It will be 0.946 multiplied by 100. So whenever you say degree, you are talking about the fraction thing. But when you are saying percentage, just multiply this thing by 100, you will get it as 94.6% as your correct answer. Next question. If sodium sulfate is considered to be completely dissociated into cations and anions in aqueous solution, the change in freezing point of water, that is delta TF, when 0.01 mole of sodium sulfate is dissolved in 1 kg of water is, your options are A 0.0372 Kelvin, B 0.058 Kelvin, C 0.0744 Kelvin, and D 0.0816 Kelvin. Option D. So, in this question, you have said that your sodium sulfate is considered to be completely dissociated in cation and anion, right? Completely dissociated means if you dissolve this sodium sulfate in water, then you will get your ions, that is 2Na plus, and your remaining what? Your remaining sulfate thing. Okay. So if you just dissolve this thing, you will get a change in freezing point. And what is this change? So this change is if you are adding 0.01 mole of sodium sulfate in 1 kg of water, you have to calculate that change. So your number of moles is given, mass of water is given, and kf value for water is also given, which is 1.86 Kelvin kg per mole. So the correct answer will be B. So it is said that whenever we dissolve this sodium sulfate, we are getting 2 moles of sodium plus and 1 mole of sulfate ion. So what will be the Ventov factor? So 2 plus 1, that will be 3. So we don't have any partial dissociation, so we can directly take the value of I as the number of particles on the product. Now molality is calculated how? How it is calculated? So we have 0.01 mole dissolved in 1 kg of water. So we'll simply get it by dividing 0.01 by 1, that is number of moles per kg of solvent. That will give you 0.01 mole per kg. So this is your molality. Now delta TF is IKFM. Okay. Delta TF is depression freezing point, I is the Ventov factor, Kf is the molar depression constant, and M is your molarity. Now we'll put all these values. So if I put all these values, that will be equals to 3 into 1.86 into 0.01, which is 0.0558 Kelvin. So this is your delta TF. Clear? Okay. Next question. Consider separate solution of 0.500 molar C2H5OH aqueous, 0.100 molar Mg3PO4 whole twice aqueous, 0.250 molar KBr aqueous, and 0.125 molar Na3PO4 at 25 degrees Celsius. Which statement is true about these solution, assuming all salts to be strong electrolytes? Your options are A. They all have same osmotic pressure. B. This 0.100 molar Mg3PO4 whole twice, which is magnesium phosphate, has the highest osmotic pressure. B. 0.125 molar has the highest osmotic pressure. And D. 0.500 molar has the highest osmotic pressure. So you have some time to solve this question. Your time starts now. Okay, so your time is up. So in this question, you are given a separate solution of this ethanol, which is 0.500 molar. Then we have this magnesium phosphate, which is 0.100 molar. Then we have this potassium bromide, which is 0.250 molar, and Na3PO4, which is 0.125 molar. And all these are at 25 degrees Celsius. Now to say that which statement is correct about all this solution. And in this case, we have to consider that all of these salts are strong electrolytes. That means they will get completely dissociated when dissolved in water. So correct answer will be A. What is the formula for osmotic pressure? It is pi is equals to ICRT. I is the Ventov factor, C is the concentration, R is the gas constant, T is the temperature, and pi is your osmotic pressure. Now, for 0.5 molar ethanoic acid, your I will be 1. Very clear, right? So pi formula will be 0.5 into 1 into RT, which is 0.5 RT. Now I will say that it is given in the question that all salts are strong electrolytes, but this is not a salt, right? So this statement is only for salt. Clear? So you could not get confused with this thing. Now if I talk about Mg3PO4 whole twice, which is 0.100 molar, then for that your I will be 5. How? Because it is a salt and it will get completely dissociated. So there will be 3 magnesium 2 plus ion and 2 PO4 3 minus ion. So 2 plus 3, that is value will be 5. So in this case, our pi will be 0.100 multiplied by I. Okay, I value is considered, multiplied by RT. Clear? That will give you 0.5 RT. Next question, for a 0.25 molar KBr will be dissociated to potassium plus and bromide minus. So I value will be 2 according to this equation. One for this and one for this. Now what will be the value of pi? It will be 2 into 0.25 into RT, which is 0.5 RT, right? Now we will calculate it for 0.125 molar Na3PO4 solution. In this case also there will be complete dissociation. So we'll get 3 moles of sodium plus and P4O3 minus 1 mole of phosphate ion. So in this case your I value is simply 4. 3 plus 1, that is 4. So we can write that pi is equals to ICRT. I value is 4, C value is 0.125 and RT is as it is. So that will give you on multiplication 0.5 RT. So this is your pi value. So from this we can say that all of them have the same osmotic pressure. Clear? See, all have the same osmotic pressure. So this is your correct answer. Next question, direction. In the following question, assertion followed by a reason is given. Choose the correct option. Assertion is when methyl alcohol is added to water, boiling point of water increases. Reason is when volatile is solute is added to a volatile solvent, evaporation elevation in boiling point is observed. Options are A, both A and R are true and R is the correct explanation of A. B, both A and R are true and R is not the correct explanation of A. Then C, R is true but A is true but R is false. And D, both A and R are false. Clear? So you have some time to solve this question. Your time starts now. So in this question, you are given a direction that we have a assertion, means a statement, and whose reason is given. We have to see that whether these statements are correct or not, and whether this reason is a correct explanation of A or not. So correct answer will be D. Now in this question, your assertion and reason type question is there. So you will be given two sentences. Second will be considered as the reason which is written here. And when we will examine A and R, and we will see that A is correct, okay, and R is true, and the correct explanation of A, then and then only we'll take the option A. Otherwise, we have different option that A is true, R is false, both A and R are false, A is true, R is true, but R is not the correct explanation of A. So this can be the cases, right? So I said that when methyl alcohol is added to water, boiling point of water decreases. So reason is given that since your alcohol is more volatile and you are adding to a less volatile solvent, the vapor pressure of the solvent increases due to the Raoult's law, okay, and hence boiling point of water increases for non-volatile solute. If I talk about the non-volatile, then it will say what? It will decrease that boiling point. But for a chilled one, okay, but for a volatile one, not the chilled one, but for a volatile one, the boiling point will decrease. Clear? Okay. Next question, direction. In the following question, assertion followed by reason is given. Choose the correct option. Assertion is A. Molarity of a solution in liquid state changes with temperature. Reason is the volume of solution changes with change in temperature. Answer option number A. Both A and R are true, and R is the correct explanation of A. B. Both A and R are true, but R is not the correct explanation of A. C. A is true, but R is false. And D. Both A and R are false. So in this question, the direction which is given, you have to is that your assertion is given, and for that one reason is given. You have to see that whether assertion or reason is correct, and whether reason is the correct explanation of assertion or not. So assertion says that your molarity of a solution will in liquid state changes with temperature. Okay, so if you change the temperature, the molarity will change. The reason is what? The reason is that the volume of solution changes with temperature. So if you change the temperature, your volume will change, and for that reason, your molarity changes. So according to the question, it is said that. Now you have to see that whether it is true or false. Okay, so answer is A, which says that both reason and assertion are true, and your reason is the correct explanation of the assertion. So assertion and reason are correct, and reason is the correct explanation of assertion. So if I talk about volume of solution, so this is a function of temperature. We know it very well, and this temperature varies with the this temperature vary the volume. Okay, so if you are changing the temperature, you are also changing the molarity of the solution. Why? Because molarity is nothing but moles of solute, and it is inversely proportional to volume of the solution. That means what are the number of moles of solute that is present in per kg of the solvent. Next question. In the following question, assertion followed by a reason is given. Choose the correct option. Options are A. Osmotic pressure of 1 molar glucose is less than 1 molar NaCl, but vapor pressure of 1 molar glucose is higher than the 1 molar NaCl. Reason is osmotic pressure is a colligative property, but vapor pressure is not a colligative property. However, relative lowering of vapor pressure is a colligative property, right? Options are A. Both A and R are true, and R is the correct explanation of A. B. Both A and R are true, and R is not the correct explanation of A. A and R is false. A is true, but R is false. And D is both A and R are false. In this question, you are given the direction that we have a certain sentence, and we have to look upon the reason that whether it is correct or not, and also if it is satisfying the assertion or not. So your assertion says that if your osmotic pressure of 1 molar glucose, which is less than 1 molar NaCl, okay, but vapor pressure of 1 molar glucose is higher than the 1 molar NaCl. So this is given in the assertion. And your reason is that osmotic pressure is a colligative property, but vapor pressure is not a colligative property. Okay. However, relative lowering of vapor pressure is a colligative property, and we know it very, very well. So correct answer is what? Correct answer is A. So both assertion and reason are true, and reason is the correct explanation of assertion. So if you are talking about a colligative property, right? Colligative, say osmotic pressure, right? So it is a colligative property, okay? But vapor pressure is not a colligative property. But your relative lowering of vapor pressure is of course your colligative property. Clear? Next question. In the following question, assertion followed by a reason is given. Choose the correct option. Assertion A. Ebullioscopy or cryoscopy cannot be used for the determination of molecular weight of polymer. Reason: high molecular weight solute leads to a low value of TB or delta TF. Options are both A and R are true, and R is the correct explanation of A. B, A and R are true, but R is not the correct explanation of A. C, A is true, but R is false. And D, both A and R are false. So you have some time to solve this question. Your time starts now. So your time is up. So in this question, you are given an assertion and you have to say that whether this assertion is right. Then you have to look upon the reason and judge that whether the reason is right. And if the reason is the correct explanation of assertion of no, or not, you have to see that thing also. So your answer is A. So both our statements are correct, and reason is the correct explanation of assertion. Okay. So the assertion is saying what? It is saying that you cannot be determining molecular weight of polymer. Okay. This cannot be used to determine the molecular weight of polymer, which is ebullioscopic or cryoscopic constant. Because why it is so? Because high molecular weight solute leads to very low value of delta TB and delta F. So if I talk about the explanation, the changes observed in this property are very small. Okay, we know that 0.000 we get in the order of 10 to the power 3 minus 3 or minus 4. So for substances whose molar mass is in the order 10 to the power 6. So a little error in the measurement of delta TB or delta TLF will cause abnormal values of the molecular weight. Clear? Okay. So this was all for today's session. Thank you.